Greetings to all panels. My name is Yuan. Today I'm going to present my undergraduate project, development of web-based e-Thesis depository system for mapping of students' preference study area and supervised by Dr. Shahabuddin S.Amerudin. So here are some overview of my presentation today. UTM's thesis manual defines thesis as a documented report of process and the result of original research. This project outcome will allow the management of FYP in an organized way and enable the study of the pattern of students' preference study area. Currently, both faculty library and Rajasari software library do not have a complete archive of the thesis. The existing thesis management is hard to maintain and eventually end up with loss of CD as well as broken hard disks. For Geoinformatics students, it will be helpful that a system shows the study area, data use, and source of data as well, so that they can know where to apply the data they need. Therefore, an e-Thesis repository system is needed to locally store and archive the thesis to prevent loss of knowledge asset. The aim of the project is to develop a web-based e-Thesis repository system that allows users, especially students, researchers, or industry workers, to review and partially assess students' thesis, followed by mapping of students' preference study area using data mining technique. In specifically, text data mining. The objective of the research is to review the existing digital thesis repository system from user requirement analysis, develop a web-based e-Thesis repository system using Django framework, map the preference location of study area of thesis, and finally evaluate the developed system using white box and black box method. The scope of research. The main data used for this project is the FYP thesis from Geoinformatics students that submitted in 2014 within 2014 until 2019. E-Thesis are defined as an electronic version of thesis that can be stored in compact disk or floppy disk. While for the e-Thesis repository system is a repository system that can manipulate, retrieve, and manage electronic thesis or dissertation. Here is some example of e-Thesis repository system. NDLTD and OATD is an international level repository system, while UTM-IR and UTM-DNS is an example of a repository system in UTM. Text mining is defined as to extract useful and significant data from unstructured data like website, message, social media posts, journal, and so on. The 5 basic text mining steps is collecting information from unstructured data, convert into structured data, identify the pattern, analyze the pattern, and extract valuable information, finally store in the database. Here come the methodologies. This is the overall methodology of the process, where each of the objectives correspond to certain phases, which is objective 1 correlated with phase 1 planning and phase 2 analysis, objective 2 with system design and development, objective 3 is developing the data mining function. And finally, objective 4, performing system evaluation with a few testers. In phase 1, first to do is to define the problem statement, identify the aim and objective of the project, and then do excessive reading for literature review. The project activity is identified using work breakdown structure. The details will be discussed in the coming slide. First thing to do in the planning is URA. Two methods were used, which the first one is the questionnaire. First, identify the target respondent to answer the questionnaire, drop the questions, and finally distribute the questionnaire using Google Form. Well, another method is the interview. First, identify the target interviewee, and then draft question based on the background of interviewee. And the critical part is to set up the interview section with interviewee. Phase 2 is the analysis. In this phase, URA will be analyzed where the questionnaire survey will be visualized in chart or table. The interview will be transcribed and analyzed and finally summarize the critical point. Phase 3 is the system design. As shown in the figure, this is the system design from the back end until the front end. The figures show the dashboard. This is the landing page for the system. Consists of a map, a point location map, a pie chart, and a bar chart. And here is the public interface. This shows the search table of search results. And this is the admin interface. In the beginning of phase 1, we start with installing the dependent module, which is the Django, a web framework with model view template architecture, PSYCOPG2, Crusoe to connect Django and PostgreSQL. PyPDF4 is to extract text from PDF into string by page or by line. SpaCy is used to cluster the text by entity to extract name entity. GeoPy is for the geocoding services. And the flowchart will show the process after the thesis PDF is uploaded. So when the thesis is uploaded, if it consists a copyright page, the PyPDF will extract text from the copyright page since it has more information in the copyright page. If there is no copyright page in the thesis, it will directly read the cover page. After both process, the PyPDF will continue to read chapter 1. The whole chapter 1 will extract into string, and then we'll run spaCy for name entity recognition. And next, the name entity will be passed to the geocoding service. All the name entity will be tried to geocode, and if the geocoding output is valid, which is not known, the output data with location will be stored in database. If done, the output data without location information will be stored in state. And next is for the visualization parts. The visualization will mainly using three methods, which is a table of query result using the Python and Django built-in search vector function, and the point location maps using Mapbox and JavaScript for each thesis. And then a few statistical chart will be generated using chart.js to show the numerical value for the text summarization and probably the number of theses based on the yield proportion. And next, in phase 4.3, the evaluation will be carried out internally using whiteboard testing carried out by the programmer or developer. And next, the breadboard testing carried out with the tester from various background, which one of them is a software engineer, public, and another one is public that did not have any technical knowledge, and a student. Come from the result for the URA. The URA is carried out for 7 days, and the proportion of the respondent is mainly from the Geoinformatics students, which consists of 78% of all, and while for industrial worker 15%, Geoinformatics lecturer 5%, and staff 2%. And this chart shows the percentage of respondents that have used an e-Thesis during their academic writing. And this chart shows the positive tendency of the responding in agreeing that having a map will show the students that having a map that shows study area will be helpful. And next is for the interview. The aim of the interview is to identify the user requirement in terms of functionality and user interface. The first interviewee is Yuan Hazli, a current FYP coordinator. He is using Microsoft Excel to manage the thesis listing, and he finds it a time-consuming process and lack of proper metadata of the thesis. So he expects for a proper database system that is up to date and easy user to get latest information, and basic query is a must. And next interviewee is Dr. Muhammad Imzam, a former FYP coordinator. He used the same method as Undergraduate, which is using a Microsoft Excel to manage the listing of student theses, and he expects to have a proper background. Due to the thesis he managed, due to the loss of the thesis metadata, while his hard disk is broken, and he said that it is helpful to show the data availability for the student, and that will ease them to get the data for their next project. And the third interviewee is Encik Muhammad Rajib, head of automation division in UTM library, and he gives information for the purpose of the UTM EPRIM or UTM IR is to comply with the concept of accessing open access collection, and the UTM IR is developed using Perl integrated with MySQL database. And he also gives the detail of thesis metadata recorded in the system. So this is the two limitation for each of the two that I've used in the system. PyPDF4 have some limitation in terms of reading text with too much empty space, and empty pages will cause the exception because PyPDF cannot extract any string from it. So set up the exception handling will be helpful. and use the find function for the applicable to fast to for a quicker search, for quicker extracting. And the specie for now, they do not have a Malay language model yet, so causing it to mislabel name entity. For instance, a location name might be labeled as organization or person. So instead of directly using it to recognize location or geopolitical entity type, I just directly recognize the name entity and try to geocode all the name entity. The geopy have some limitation in the, but the limitation is mostly due to the geocode the services, which is nominating in this system. By set up the time up as known, or will settle the service time up limitation. Set the contributor to Malaysia will limit the search, and so the process will be faster. Here was the step to use the system. At the landing page, the user can click on the search button, search thesis button, to redirect themselves to a search page. User can type any keyword in the search box to search. When search button is clicked, all the thesis related to the keyword will be listed out. And here is the system admin. At the landing page, admin can click on the admin login button, and then at the top left, click on the upload button to redirect admin to the upload page. We have three types of the thesis format available to upload. Because the thesis format is changes from years to years and might change in the future. And next, when the admin is redirected to upload page, the browse button is click the browse button to search through the select the thesis PDF file, and then click upload to upload the file. The upload time maybe varies because of the name entity numbers and the internet connection for the geocoding. So here is the Django admin site. Django admin site is for the system admin that allows system admin to manipulate the data inside this database. And this is the final output of the landing page, having two buttons here, a map that plot up all the study area, and a pie chart so the proportion of thesis by year in the database in the repository, and the text summarization result. And this is the guest interface, user interface when queried by the supervisor's name. This is the admin interface, where this is the back to the landing page button, view dashboard, and the upload button. From the whiteboard testing, the accuracy is and the time is observed, and out of the 103 uploaded theses, 77 of them is successfully geocoded. And for the time is for a good connection, it might be 50 to 60 seconds, or but sometimes if the connection is slow, the time consumed will be more than 1 to 2 minutes. So here was some comment of the texture in aspect of dashboard, user interface, and functionality. And based on that, the upload process is still quite slow, maybe causing by the geocoding process. And finally, the conclusion is all the objective has been successfully achieved. For the objective 1, The literature and UA is done to examine the opinion of users. And evaluative tools, 103 theses is uploaded. 77 of theses can have metadata extracted automatically with minor errors, such as loss of some character. And the rest of the thesis were uploaded using manual entry form. Therefore, the process cannot consider as fully automated. And the third, a map is of the location is plotted, and the system is evaluated with the tester with their recommendation is highlighted. And next is some recommendation. The default value is set up for the basic data that is filled to be abstract, so that the page, the system did not crash during the upload process, and normalize the database to avoid redundancy of the supervisor's name or for further usage in the future. And the third recommendation is to apply a different geocoding service such as Google Geocoding API or other to improve the accuracy. And fourth is to apply bootstrap template for the better organized, responsive, and attractive UI. And finally, integrate with the data visualization software for fast and organized dashboard creation for a better view for the data visualization. So that's all for my presentations. Thank you for your view.